Okay, so welcome back. Now we're going to do some examples. Oops. So now we're going to do some examples of applying this technique. Okay? So let's start with the first one. So the first one we have, again, polynomials, right? Rational expressions. So all of these are rational expressions. And so first thing we want to do is evaluate that this form here gives us 0, 0. 0 over 0. Okay? So if we apply 3, so we evaluate the top at 3, what do we get? We get 9 minus 9, which is 0. And on the bottom we get 2 times 9 is 18, minus 15, which is 3. 3 minus 3 is 0. So we do get 0 over 0. So you want to make sure that you do get the proper form. So now that we've got these ratio of polynomials, let's see if we can factor these and see if they cancel. This would be a good candidate for factoring and canceling. So now again, I'm not going to show you how to factor these. You should know how to do that from previous classes. So again, if you're a little rusty on some of the algebra and stuff, go back and practice. Okay? So the first thing, I'm going to factor the top and the bottom. So if you factor the top, you get x times x minus 3. And the bottom will factor into x minus 3 times 2x plus 1. Okay? And again, you could use the AC method, method of decomposition, so on. Okay? Okay, so notice that we've got a common factor in the top and the bottom, so we're going to cancel those out. Oh, don't forget, see, I just made a mistake here. And this is a common mistake, especially when you get going and you get focused on what you're doing. Don't forget to take the limit with you, okay? Gotta take the limit with you. Okay? And then this would be equal to the limit as x approaches 3 of x over 2x plus 1. Okay? And then finally, we can apply the limit laws. Okay? And we will not get 0 over 0. So if we apply the limit laws, then this limit will equal what? 3 over 2 times 3 plus 1, which is going to equal 3 over 7. And that is the answer, 3/7. So the limit is 3/7. Okay. Now, what about this one? Here, again, evaluate it, make sure you get the proper form. You get 0 over 0. So if we put a negative 1, we get square root of 1, which is 1. We get 1 minus 1, which is 0. And we get negative 1 plus 1, which is 0. So we do get 0 over 0. So now, it has a difference in it with a radical, square root, right? So now what I'm going to do is I'm going to multiply the top and the bottom by the conjugate of the numerator, which is going to be this. Now, by the property of multiplying by conjugates, this is going to give me this. The top is going to cancel out very nicely. Okay? Because this times this will give me x plus 2, and then the cross multiplying will cancel each other out because I'll get a negative and a positive, so that will cancel each other out, and then I'll get a minus 1. So I get x plus 2 minus 1 on the top. Okay? And then I get an x plus 1 times the square root of x plus 2 plus 1 on the bottom. Now here's the thing. Don't be so gung-ho to multiply this out, because what we're looking for is things to cancel. Okay? Because if you multiply this thing out, you're just going to get another polynomial with a radical in there. Okay? So don't be so gung-ho to start distributing and expanding this out. So let's simplify the top. So the top becomes what? X plus 1. Well, there you go. Look. Now we've got something that cancels. Now, this won't always work. And you won't always have to do this, but look for it. And now we get the limit as x approaches -1 of 1 over the square root of x plus 2 plus 1. And now we can use the limit laws, and we will get 1 over the square root of -1 plus 2 plus 1, which is going to give us what? 1/2. And so the limit of the original expression is 1/2. Okay. So now, the last one that we'll do in this video is dealing with a complex fraction. So again, the first step when you're dealing with complex fractions is just simplify the fraction. But again, you can verify that this does give you an indeterminate form. Okay? So we're going to plug in 1. Here we get 1/2 minus 1/2, which is 0. And we get 1 minus 1 on the bottom, which is 0. So we get the correct form. But let's simplify this expression. Okay? So the first thing I'm going to do is I'm going to get a common denominator on the top. And so I'm going to write this as, again, I'm going to get a common denominator. So this is going to end up being 2 minus x plus 1 over 2 times x plus 1, all divided by x minus 1. Okay? Oh, I dropped my limit again. Okay, so now I'm going to continue on. So this is going to be the limit as x approaches 1. Now I'm just going to keep simplifying the top. So this is going to be minus x minus 1, which is going to become 1 minus x on the top. So it's going to be 1 minus x over 2 times x plus 1 divided by x minus 1. So now here's what I'm going to do. At this point I'm going to flip this up, right? So watch how I'm going to do this. Okay, so now I'm going to write this as a product of the reciprocal, right? So I'm going to write this as the limit as x approaches 1. And now this is going to become 1 minus x over 2 times x plus 1 times the reciprocal of the bottom, which is going to be 1 divided by x minus 1. Okay, now it seems like at this point nothing's going to cancel, right? But notice that I've got a 1 minus x here and an x minus 1 here. If I factor out a -1, it'll flip them. So let's do that. So this is going to be equal to the limit as x approaches 1 of negative x minus 1 over 2 times x plus 1 times 1 over x minus 1. And now I can cancel the x minus 1 because they're a common factor on the top and the bottom. And I get my final result, or the final limit anyway, limit as x approaches 1 of negative 1 over 2 times x plus 1. And now I can use the limit laws, right? Because I don't get 0 over 0 anymore. So now I can just apply the limit laws. I'm going to get negative, what? 1 over 2 times 1 plus 1 which gives me a negative 1/4. Okay, and so that's how you apply the techniques. Now we're going to come back and do another example in the next video, so we're not done. Have a great day.